calculus lesson on 3.8, exponential growth and decay. Many of the natural phenomena, like growth and anything that grows or decays, right? The quantities either grow or decay, right, at a rate proportional to their size. So the rate is proportional to their size, right? That squiggly in the middle means proportional, right? So we could let whatever the value be y, then we have dy dt over time, change in y and change in time is equal to k times some value y, right? So that's the relationship we have. Taking that relationship and separating them into the respective places, I got 1 over y is a dy is equal to k times dt. Remember, k is just constant, right? So we are going to integrate both sides like this. Then just because ln of absolute value y is equal to k plus c, I'm just putting c on one side of the equation, and we e both sides, and we're going to end up with this, e to the k plus c. But we know that this is equal to what? E to the k times e to the c, and that's a c, right? So on the right hand side, we get c and e to the, I'm sorry, that's a t right there, my bad. Forgot to put a t there. All right, there you go. Kt. But we know that the constant could either be positive or negative, right? So we don't really need an absolute value here, right? It's all implied. So there you go. Okay, so this is what we call a general solution. Once we find the value of c, the constant, then it's a particular solution, right? All right, guys, could you write this down? So when the k is greater than 0, we call it the law of natural growth. And when k is negative, it is a law of natural decay. And from the previous lessons, we know that that's what that looks like. And that's what that looks like, right? Yeah. All right, guys, so let's just move on and maybe fill in a couple of more things here. So y is considered y naught at time 0. Okay, so when you have y is equal to c e to the kt like this, right? Then y of 0 is c times e to the k times 0, but that's 1. So I just told you that the y naught, so this implies that the y naught is equal to the c that we just had over here. So we could replace it. Therefore, right, y of t is y naught times e to the kt. So this is known as a particular solution because y is equal to y sub 0 is the initial value that we know, right? So c, when you call it c, it's telling you it is a sum number, right? And y naught is a little more specific. It's a very specific value. It's an initial value, right? That's given to us, all right? It's subtle but important. Okay, guys? All right, let's look at the first, oopsie. Let's look at the first example here. Okay, we got a lot of stuff. They give us a bunch of numbers over here. Let's not read that yet, because I like to know what's going on first. Assume that the what's going on, the rate of the growth of bacteria is proportional to the number of the bacteria present. So that right there tells me that dy dt is k times y. So y represents the number of the bacteria. A freshly inoculated bacterial culture contains 100 cells. So that's telling you that y naught is equal to 100. 60 minutes later, it was determined that they have 450 cells. So that tells me that y of 60 is 450. Okay? So we have to break this down, guys. Okay? So once we do that, as the note indicates, we need to put them in a separable differential equation. So we need to demonstrate this every time, right? Because we're just learning the material. So I want you to do this. So this is the minimum work that I'm willing to take for this. KY, that's an important step. And we know that we could do this. KT, and we could integrate this way, right? So that's ln of absolute value of y is equal to, I'm sorry, that's dt. So that's kt plus c. And then at this point, we could sort of see in our heads the e here, and that comes down to the front. We could get rid of the absolute value. So I'm going to let you sort of say that y is equal to c, e to the kt right away. But we also know that this right there is equal to y naught, isn't it? But you could show that. So that's the first thing that you should do. The second thing over here is that y of 0 is a c times e to the kt, which is 100. But I forgot to put a 0 right there, didn't I? So this thing becomes 1, so c is 100. Therefore, y is equal to 100 e to the kt. Now, if instead of this, you instead said, well, since y naught is equal to 100, therefore, if that's true, I'm okay with that too, right? All right, guys. So what's the next step here? Oh yeah, that's right. We have, it's asking, we have this, in 60 minutes is 450, right? Right. All right, let's do that right now. So, number 3, we have, what is this? Y of 60 is 450. So that tells me that it's 450 when you plug in for y, which is equal to 100 e to the k when this is 60. Divide both sides by 100, 4.5, 60k. So that is what? ln of 44.5 over 60. That approximately should be 0.02507. Therefore, y is equal to 100 e to the 0.2507 t. Well, there's something that I'd just like to point out real quick. I think it's fairly important. So this is a standard way that which we teach this thing. But have you wondered what would have happened if instead of putting this, I mean, I think it's kind of nice to have like four significant figure, you plug it in as a k, and create that as a procedure. So, you know, but this is a math class. But what if we just plug that in? What happens? Let's figure that out, shall we? All right. If you did that and replace the k right there, then y would have been 100 e to the ln of 4.5 or 60 and a t. If you rearrange that a little bit, right, it becomes ln of 4.5 to the t over 60. But it's not ln of 4.5. But where would we get that in the first place? Well, that was, if I'm not mistaken, hold on, 450 actually, right? Oopsie. That was a 450 over what? 100 over 60 right there. So let's break that down. So y of t was y naught, and that 100 is also a y naught, and that's a y final. So that is the initial size. It became 450 in 60 minutes. So that's a time period. So this is what we're looking at, right? So that was ultimately the idea behind it, okay? The idea of exponential function is that you have the same ratio that you multiply over and over again, right? Same ratio over the time period p. So if it's double, if the value doubles every 10 years, you just put 2 over here. For half-life formula, you go 1 over 2. every, I don't know, 10,000 years, right? Yeah, so this is actually the I think the most accurate one, but we do this in science. You know, it just creates a nice procedure, right? Well, anyways, we could use this value 4.5 if we wish, right? So the alternatively, knowing that, we could see that y is equal to what? 100. So 4.5 to the power, the ratio is 4.5 every what? 60 minutes. I suppose you could use that if you wish. Okay. All right. So instead of doing it that way, I could have said, you know, that right there is the same thing, because 450 over 100 is 4.5, right? So in 15 minutes, what is it? So y of 15 is 100 to the 4.5, 15 over 60. So that's 1/4 power to the 4.5 times 100. Put that in a calculator and you should get 145.65. How long does it take to double? So we're looking for what is y of t, which is twice the y naught, right? So that means that y of t is equal to what? 100 times 4.5. T over 60, that's right, twice the 100. So that's just 2. We ln both sides, and we're going to end up with t over 60, ln of 4.5, ln of 2. So t is equal to ln of 2 over ln of 4.5 times 60, I believe, right? And that should give you approximately 27.65 if I'm not mistaken. So it will take you 27.65 minutes to double the population. Okie dokie. All right, guys. Okay, for the last one, why don't you try this on your own the best you can. Okay, pause the video, please. All right, guys. The way you probably should have read that is this is day 0. This is t is equal to 30, 30th day, right? And how many days after will it reach 100? So this is more like, what is y of t is 100. Question is, what is that, right? And another thing that you should look at is this right here. It's proportional to the population, which tells you that dy dt is k times y. And y being the population of the wasps. All right, guys. Here's the answer. Step number 1, pretty straightforward. Number 2, the May 1st is d equal to 0. Y naught is 10. So you could have gotten that right away. And then substituting for 50, I found k to be ln of 50. This time I just wrote it as it is. I think it's better, you know. And I don't need a calculator. That's better, right? And you don't have to use it until the very end. And it's more accurate this way anyways, right? And then for to find the t is equal, when y of t is equal to 100, plug in all the values, works out nicely. T is equal to this. If I say no calculator, my answer that I'm looking for is that. If I do allow a scientific calculator, obviously I'll be asking for this. All right, guys, that is it for me today, and I shall see you in class. All right, have a good night.